So we are starting Unit 11 in the second semester, and the first topic is evaluating sine, cosine, and tangent. Okay, so this first part we're not exactly evaluating, but we are locating where is the terminal side for each of the angle measurements. So for 7 pi over 6, that's going to be in the third quadrant, and it's going to be just past pi, all right? So the initial side will always start at 0. And then we open upward for a positive angle. So positive 7 pi over 6, and it will terminate here. And I know it's just past pi, this is pi, but you can rewrite pi as 6 pi over 6. And then we have 1/6 past 6 pi over 6. So that's 1/6 past 1, so it's just barely past pi. And this is part of the family of sixes. So there are 4 of them, and all 4 of them are closer to the x-axis. The first one is pi over 6, which is here. The second one is 5 pi over 6. The third one is 7 pi over 6. And then the fourth one is 11 pi over 6. So they create this bow tie that is closest to the x-axis. So family of 6, x, closer to the x-axis. 7 pi over 4 is the next family. 7 pi over 4 will be located in the fourth quadrant, and the family of 4s split the quadrants in half, right? The family of 4s deals with the 45-45 triangle, therefore it will be halfway through each of the quadrants. And this is for the family of 4s. The first part, or the first angle that is part of the family of 4s is pi over 4 in quadrant 1. In quadrant 2, it's 3 pi over 4. Quadrant 3, that'll be 5 pi over 4. And then quadrant 4 has 7 pi over 4. And this opens up in the positive direction, and we can call that beta. And then the first one was just theta. The last one is the family of 3s, but this one's negative, which means we're going to start from our initial side at 0. And then we are going to open up downwards instead of upwards. So you can use the positive angles for this. So if I think of 2 pi over 3, that's going to open up into quadrant 2, which would be here. So this tells me that I travel a full quadrant plus a little bit more to get to 2 pi over 3, which means I will do the same thing in the opposite direction to get to here, which puts me in quadrant 2. Something else you can do is you found 2 pi over 3, you can just reflect it over the horizontal axis, and that'll get you to the negative coterminal angle. So we'll call this alpha. And this is the family of 3s. So in quadrant 1, the first part of the family of 3 is pi over 3. Quadrant 2 is the 2 pi over 3. Quadrant 3, which is coterminal to negative 2 pi over 3, is 4 pi over 3. And then in quadrant 4, we have 5 pi over 3. And the family of 3s create a bow tie that wrap around the y-axis. Bow tie, it's this. So it looks like that if I were to sketch it out completely. And then the bow tie for the family of 6s is around the x-axis, looks like this. It's just too much. All right, so the second part, we are talking about a specific angle. So our theta is equal to 60 degrees, okay? And this is a specific triangle. This is our 30, 60, 90 triangle. So if you recall, it was a while back. So if you don't remember, don't stress about it. We'll get it back to you. In the unit circle, we use 2 special triangles, 30, 60, 90, and 45, 45, 90, okay? Most of our coordinates come from the 30, 60, 90 triangle. In each quadrant, 2 of the points rely on that 30, 60, 90, and then 1 of the points relies on the 45, 45, 90 triangle, which is where we get our coordinate points from. So on this side, this is known as the adjacent side because our theta will always be at the center. Okay, it'll always come from this angle here. It's adjacent, which is also the x value, which in this case, the x value is equal to 1/2, which is equal to cosine of 60 degrees. And then in radians, this would be pi over 3. So all of this is equivalent. It's the adjacent side, it's equal to 1/2. It's cosine of 60 degrees, which is equal to cosine of pi over 3. And I can use all of that based on this coordinate. The same pattern can be used for the vertical side. So this is the opposite side. It's opposite the angle. This is the y value. It's equal to root 3 over 2. And this is equivalent to evaluating, for the vertical or the opposite side, it's sine of 60 degrees, which if we were to rewrite this in radians would be sine of pi over 3. And again, I have this based on the coordinate point. So this all stems back to what you learned in geometry, SOHCAHTOA, all right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Now, the reason why we do not have like a fraction for this is because the hypotenuse is always 1 for a unit circle. Unit circle means the hypotenuse is 1. Anytime the hypotenuse is not 1, it is no longer a unit circle. So for a specific unit circle, we use these special angles to figure out what the outputs will be. And yes, these are both considered outputs. These are both outputs. So sometimes the unit circle is a little confusing because typically for a function, we have a single input and then a single output. The input for our unit circle are angles. Okay, so we have one input here, and then on the unit circle, the x value is an output for cosine, and then the y value is the output for sine. So one input will always result in two outputs. So x and y are outputs in this case. So just a quick wrap up, the sine theta is going to be the y-coordinate, which based on SOHCAHTOA is opposite over hypotenuse. The cosine theta will be your x-coordinate of the unit circle, which is adjacent over hypotenuse. Whoops. And then tangent theta, that's going to be your y-coordinate over the x-coordinate. And or you could also say, let's rewrite this as, this is equivalent to sine theta over cosine theta, which gives us opposite over adjacent. And the question is, what does theta represent on the unit circle? Theta is your input, or is the input. And theta can either be in degrees, or it can be in radians. If you plan on, so in this course, we will switch, there's modes in our calculator that will switch between depending on the scenario. But as we get through the semester, we will use a lot more radians because in calculus, that's all we use, right? It's strictly radians. So evaluating. So with each of these, you want to include a sketch whenever you're evaluating. It doesn't have to be super detailed, but it should at least show where you are evaluating, okay? Is it splitting the quadrant? Is it a family of 6 where it's closer to the x-axis? Or is it a family of 3 where it's closer to the y-axis? So it doesn't have to be a perfect, like you don't have to get the protractor out and, all right, pi over 4, got to make sure this is 45 degrees. Just as long as it looks like it's splitting that quadrant, you're fine. It doesn't have to be super detailed. Now for sine, we are using the y-coordinate, okay? But luckily for the family of 4s, it will always be root 2 over 2. So we just have to determine, okay, is this positive or negative? Well, for sine, I can see that it's going up in the positive y direction, so this will be positive root 2 over 2. You can also use 1 over root 2. They are equivalent, right? But for the sake of consistency, so that all of my coordinates have a denominator of 2, I will use root 2 over 2. Sometimes you'll see me use 1 over root 2. If you have me in calculus, I'll use it 1 over root 2 because it's less values to work with, but in this course, we'll work with the consistency. Cosine of 3 pi over 4. This is another reason why I require sketches, is because now you can use this in order to help get a sketch for this. The larger your fractions get, typically the angle is more difficult to remember. So if I know pi over 4 is in quadrant 1, then that means 3 pi over 4 is in quadrant 2. And we are looking for the x-coordinate. So again, it's family of 4, so it has to be some form of root 2 over 2 for sine and cosine. All right. Now, in the previous problem, we were going in the positive y direction. In this one, we are going in the negative x direction. Therefore, this will be negative root 2 over 2. So for sine, I only care about what's happening vertically. For cosine, I only care about what's happening horizontally. So now we'll have sine of 4 pi over 3. Okay, so family of 3's, they will be closer to the y-axis. There are 4 of them. Okay, quadrant 1 is pi over 3, 2 pi over 3, which means 4 pi over 3 will be here in quadrant 3. All right, so for the family of 3's, we're no longer in the family of 4's. For family of 3's and 6's, we have 2 options for sine and cosine. It's either 1/2 or root 3 over 2, okay? Now, for this one, for sine, I only care about what's happening vertically, so we're going down. Because this one is further away from the x-axis, this one is going to be root 3 over 2. And I can see that it's further away because in quadrant 3, the other angle that deals with 30, 60, 90 would be over here. And for this one, the sine would be the smaller side, which would be 1/2. All right, so we're dealing with the 30, 60, 90 triangle that's further away. Therefore, the vertical distance is larger than the horizontal distance. Now, because this is going into the negative y direction, we want negative root 3 over 2. Cosine of 5 pi over 3. Again, I already established that 4 pi over 3 is in quadrant 3, so that means 5 pi over 3 is in quadrant 4. And now we're worried about cosine, okay? So if I were to draw a little triangle in there, I have a 30, 60, 90 triangle, all right? It's not a 45-degree angle, therefore it has to be the 30, 60, 90 triangle, okay? For if it's not on either the horizontal or vertical axis. So I have a side here and I have a side here. This is the longer side, this is the shorter side. We're only worried about the horizontal distance, all right? And since x, or the horizontal distance, or that side of the triangle is smaller, I have 2 choices, 1/2 or root 3 over 2. 1/2 is less than root 3 over 2, and we're traveling in the positive direction, so it's positive 1/2. Moving on to tangent, again, a quick sketch. Pi over 4 is splitting quadrant 1. Now for tangent, we use y over x. Now this triangle here for family of 4's, we are dealing with a 45-45 triangle, right? So these 2 sides are the same, okay? Which means the ratios of those sides will always be 1. Now for a family of 4's for tangent, it'll either be positive 1 or negative 1. If the 2 coordinates have the same symbol, the same sign, they'll be positive 1. If they have opposite signs, like one is positive and the other is negative, then it will be negative 1. But because they are both positive in quadrant 1, we will have positive 1. Tangent of 3 pi over 2. So family of 2's will be on your axes, the vertical and horizontal. Pi over 2 is up here. This is just pi, which means 3 pi over 2 is down here. So we're looking at this one. So we need the x-coordinate and the y-coordinate. This is going to be 0, 1. And tangent is going to be y over x, which means we have 1 over 0, which means because we can't divide by 0, this one is undefined. Graphically, what we'll see in the next lesson, this means there is a vertical asymptote for tangent at 3 pi over 2. All right, negative pi over 3. So if I were to map out pi over 3, that would be here. If I want its negative coterminal angle, I can do a vertical reflection. So that means we are down here. So this is equivalent to sine, so we have pi over 3, 2 pi over 3, 4 pi over 3. This is equivalent to sine 5 pi over 3. Coterminal angles will have the same results. So if I look at this, this is closer to the y-axis, which means the longer side of this triangle is going to be vertical. So that means we have negative root 3 over 2. And then cosine of 11 pi over 3. 11 pi over 3 is not on the unit circle. The largest family of 3 that we have is 5 pi over 3. So we're going to have to find a coterminal angle so that we can evaluate this. So obviously it's too large, it's too big. So what I can do is I can subtract 1 revolution, which would be 2 pi. But if I want to evaluate this, I need to have a common denominator. So I have 11 pi over 3 minus 6 pi over 3, which gives me 5 pi over 3. So that means this is equal to cosine of 5 pi over 3, which we already evaluated for number 4, which is equal to 1/2. So you'll have to make some adjustments sometimes in order to evaluate these. And then in this corner is just a unit circle. It doesn't include tangent, but I'll draw them in real quick if you want to include them on your notes as well. Because I don't think I put them on the key, but go ahead and do it. So this is taking all the way around. It's just y over x, y over x, y over x, y over x. So like at 7 pi over 6, because all of the denominators are the same, we can ignore those, which means I have negative 1 over negative root 3. So that's just 1 over root 3 because they're both negative. And then this is just negative root 2 over negative root 2, just 1. And then here I have root 3. And then undefined. And then over here we have negative root 3, negative 1, and then negative 1 over root 3. Depending on what you look at, you could also see negative root 3 over 3. These are equivalent, okay? So don't let that trip you up. All right, the last part on this page is reference angles. This is kind of brief, but we're going to represent a reference angle as theta sub r. So what is a reference angle? A reference angle is the acute angle between an angle's terminal side and the x-axis. And in order to find a reference angle, you want to work within the restriction from 0 to 360 degrees or 0 to 2 pi. And I'm not including the 360 because it's the same as 0, and I'm not including the 2 pi because it's the same as 0 pi. So let's think about this. So I'm going to set up, it's going to be different depending on the quadrant you're in. So let's start with quadrant 1, which is going to be the easiest one. Because if I have an angle here, we'll call it theta, and I want to know what the reference angle is. And then this will be, we're calling the horizontal axis the x-axis, because that's what we used in the definition. So it's the acute angle between an angle's terminal side and the x-axis. So that means in quadrant 1, if I want my reference angle, theta sub r is equal to theta. We don't need to change anything, because it's already less than 90 degrees. Quadrant 2 is going to be a different story. So we have in quadrant 2, let's call this my terminal side. They're all going to look like family of 4s, but whatever. So in quadrant 2, to find theta sub r, or the reference angle, I need, so the actual angle is this. This is my actual angle, all right? So that we'll call it 3 pi over 4. Okay, we'll say this is 3 pi over 4. The reference angle for 3 pi over 4 is going to be whatever is in here, okay? And if we think about this, this is already pi, this is 3 pi over 4. So if I want to find the difference between these two, that gives me the space in here, all right? Because I want that acute angle that's between the terminal side and the x-axis, okay? So to find that, I can do pi minus theta, or 180 minus theta, because that will give me the difference between these two, which is going to be that acute angle between the terminal side and the x-axis. Quadrant 3. It's going to be a very similar approach, but say that we have our initial side here, and our terminal side will be here. So I'll try and draw, let's see, I'll put it in black. So our reference angle is here, reference angle is here, and then now we have this angle that opens up, which means our reference angle will be here. It'll be inside of this one. Oh, you know what I should have done? Let me clarify. So this is theta, but this is also theta sub r. That's why it's a little confusing. Okay, so technically my theta is over here. It's this angle. And then on the inside, that is theta sub r. Okay. And then I'll also label that this is pi because we're using it in our formula to find the reference angle. Now for this one up here, the angle we'll call theta is this, but our reference angle will be here. It's inside of here. So to find our reference angle, we have our full angle theta, all right, the green one, going all the way around to 180, past 180 to create that. Our reference angle is the angle from 180 to the terminal side, okay? So that means if we want that theta sub r, that reference angle, we don't want all of theta. We only want the portion after 180. So in quadrant 3, we do theta minus pi, or theta minus 180 degrees. Quadrant 4. So let's say that we have our initial side, and then our terminal side wraps all the way around to here. So again, the green, we'll call that theta, and then our reference angle is going to be the acute angle between the x-axis and the terminal side. So it's going to be this angle here. So to find the reference angle, theta sub r, I only want the space in here, okay? So we have this theta that's greater than 270 to end up in quadrant 4, but I only want the space between 360 and 270. Or I'm sorry, 360 and theta. So to find the reference angle, we'll do 2 pi, which is 360, minus theta, or 360 minus theta. And that's how you find the reference angle in quadrant 4. So a couple examples. Let's see. We'll call this A. What is the reference angle for 7 pi over 6? Well, 7 pi over 6 is in quadrant 3. Okay, 7 pi over 6 is going to be here. So if I want the reference angle for quadrant 3, theta sub r is going to be equal to, I'm looking in quadrant 3, my theta is 7 pi over 6. I'm going to subtract pi, which means in order to evaluate this, I need to find a common denominator. So that'll be 7 pi over 6 minus 6 pi over 6, which equals pi over 6. Now, you don't have to show all of these steps. If you can we already talked about how this is pi, and then if this would be 7 pi over 6, the difference is going to be 1 pi over 6, okay? But some of these, they'll be a little more complex, so you might have to work out the common denominator and find the difference. Part B, let's do 275 degrees. So 275 degrees, if 270 is here, 275 is just past it. So it's barely in quadrant 4. But we want that acute angle, so we have to be accurate. So our reference angle, if I'm in quadrant 4, we're going to do 360 minus 275. Which is going to give us 85 degrees. Yeah, so we are 5 degrees past that 270, which means our acute angle is just going to be 85 degrees. And then part C, the last part, let's do negative 5 pi over 3. So negative 5 pi over 3, this is why I included this up here, the restrictions, because you're going to want to use angles from the unit circle to help you find the reference angle. Negative 5 over 3 is negative, and it's a pretty large angle as well. So if I think about 5 pi over 3, the positive one, that's going to be in quadrant 4. But if I have negative 5 pi over 3, I can reflect that vertically, and I can find it in quadrant 1, which means negative 5 pi over 3 is also pi over 3. They are coterminal angles. They are exactly the same. Hold on, let me double check this. So 5 pi over 3 is going to be in this quadrant. Negative 5 pi over 3, we pass 1, 2, 3. Yeah, so we'll be in quadrant 1. Quadrant 1. Something else we can do is you can add 2 pi. So if I have negative 5 pi over 3 and I want to add 2 pi to find that coterminal angle, that'll be 6 pi over 3. So negative 5 plus 6, we get pi over 3, which again is in quadrant 1. So in quadrant 1, your reference angle is the angle itself because it's already less than 90 degrees. And because theta sub r is equal to theta, that means theta sub r will be equal to pi over 3. All right, hope this helps. Thank you.